Now that the midterm's over, I want to walk through some of the questions that you saw on the midterm um, because, guys, you're going to see that information again on the final exam. And some of you are making what I think are just common errors or errors because you're rushing through the problem, you're not paying attention. So I want to work through some of these and hopefully you won't make the same mistakes again on the final exam. So one of the first questions that you had asked you to select all the rational numbers. Okay, so here the key word is that you want the rational. And so you have to remember that rational is any number that can be written as a fraction like P over Q. So it's obvious from looking at this list then that negative 17 over 3 is a fraction. Included within that, typically fractions can be converted to terminating decimals. For example, one that you're probably very familiar with is think about that 1/2 could be converted to 5/10 or 0.5. And so if you have a terminating decimal, which means one that ends, and so then that becomes obvious that 0.33 is a rational number. Also, with rational numbers, you can have a repeating decimal. An example here that you might be familiar with would be like 1/3. If you look at 1/3 on your calculator, it's 0.3333, and it keeps going on forever and ever. So that's a repeating decimal that repeats a pattern. So if you look at the decimal values you have here, you'll notice that 5.12121212, you have that repeating pattern of 121212. Now the other decimal here, 5.122122, okay, so it's not a repeating pattern. That leaves the two square roots. And so in order to make a decision about the two square roots, you may want to simplify it. Well, the square root of 64 is 8. And 8 could be written as a fraction by writing it as 8 over 1. So that lets me know that square root of 64 is actually a rational number. Square root of 63, I don't believe is a perfect square. If I look at it as a decimal, it's 7.9372539333. So it's not repeating and it is not terminating. So square root of 63 is a decimal that just keeps going on forever and ever. It's non-terminating. So therefore, it is not a rational number either. Now, what that means is that the square root of 63 and this non-repeating decimal, those are considered irrational numbers. Okay, so you have to be careful, guys, and pay attention to the instructions, whether it says rational or irrational. All right, then question number 2, it says evaluate the expression. Guys, this is a straight flat out plug and chug. Okay, so wherever there is an x, you're going to put -1. So I would have 4 times -1 cubed minus 2 times -1 squared plus 5 times -1 minus 3. Okay, and then you have to do the math. Now, you can do this on your calculator, but if you do, you need to make sure you put parentheses around the -1 so that the calculator will read the fact that it is negative. So if I multiply this out, 4 -1 cubed is -1 times -1 times -1, which ultimately gives me a value of -1, minus 2 times -1 squared. So it's -1 times -1 So minus 2, negative 1 times negative 1 is positive 1. Plus 5 times negative 1 would give me negative 5, or minus 5 minus 3. Okay, and then again, I'm going to continue to do the math. It'd be easier just to use your calculator, but I'm working it out for you. 4 times negative 1 is negative 4. Minus 2 times 1 is minus 2. Minus 5 minus 3. I'm going to add and subtract left to right. Negative 4 minus 2 is negative 6. Minus 5 is 11. Minus 3 is negative 14. One of the questions that a lot of you guys missed was rationalizing the denominator. What you have to realize here is that in this particular problem, you have a binomial in the denominator. You have two terms. And so when you have two terms, you use the conjugate. The conjugate is a fancy way in mathematics to say the opposite. So I have the same two partners, square root of 2 and 3. The given one is a minus, so I need the positive. So I have square root 2 plus 3. Now, it may help you here to put parentheses and realize that square root of 2 plus 3, as well as square root of 2 minus 3, is a group. They go together. Okay, so I'm going to have 5 times the square root of 2 plus 3 over square root of 2 minus 3 times square root of 2 plus 3. Okay, so in the numerator, I'm going to use the distributive property, and I'm going to distribute the 5. Remember, we got to go all the way through the parentheses. So I have 5 times the square root of 2 plus 5 times 3 is 15. In the denominator, I'm going to use full. So I have square root of 2 times square root of 2, which is square root 4, plus 3 square root 2 minus 3 square root 2 minus 9. So if I simplify that, I have 5 square root of 2 plus 15 in the numerator. Square root of 4 is 2 plus 3 square root 2 minus 3 square root 2 divides out, and I have minus 9. So I have 5 square root of 2 plus 15 all over negative 7. Now, normally we don't put a negative in the denominator, so really we would actually write this final answer with the negative out front. So you have negative 5 square root 2 plus 15 over 7. Number 4 asks you to multiply together two trinomials. And I think what a lot of you guys forgot on this particular problem is that you have to distribute. You have to multiply each term in the first parentheses times each term in the second parentheses. So I'm going to do this in color. So I'm going to start with x squared, and I'm going to multiply it times x squared, which gives me x to the 4th. X squared times 2x becomes 2x to the 3rd, and x squared times plus 2 is plus 2x squared. And then I go back and I start over and I do negative 2x. So negative 2x times x squared is minus 2x cubed. Minus 2x times plus 2x is minus 4x squared. Minus 2x plus 2 is minus 4x. Please, 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 please be careful and watch those signs. If you get in a hurry, you'll mess them up. Then we have to do plus 2. So positive 2 times x squared is plus 2x squared. Positive 2 times positive 2x is plus 4x. And finally, positive 2 times positive 2 is positive 4. After you've finished all the multiplying, you go back and you combine like terms. So I have x to the fourth, 2x cubed minus 2x cubed is 0. I have plus 2x squared plus 2x squared, which makes 4x squared, minus 4x squared. So that also zeroes out. I have negative 4x plus 4x. That also zeroes out. And I'm left with plus 4. So my answer ultimately is x to the fourth plus 4. The number 5 asks you to factor. And so you have 3x cubed plus 81. And remember, the first thing you want to do whenever you're factoring is look to see, do you have a greatest common factor? And I do. So I have 3x, as a common factor here, I have 3 in common. So I'm going to factor it out. That leaves me with x cubed plus 27. Then I notice that I have two terms, and typically when I have two terms, it's either going to be the difference of two squares, the difference of two cubes, or the sum of two cubes. Well, I notice immediately here two things. One, I have a cube because I have the exponent of 3, and I have a plus. So what's left here in this parentheses is a sum of two cubes. And if you will, the formula for factoring the sum of two cubes was given to you at the beginning of the exam. So if you want to look back, it's a plus b, a cubed plus b cubed factors as a plus b, a squared minus ab plus b squared. Every time, all the time, that's how you factor the sum of two cubes. So if I continue with this process, the 3 that we factored out at the beginning is still there. Breaking down my cube, to get x cubed, I would have used x. To get 27, I would have multiplied 3 times itself 3 times. So I have x plus 3. Then I square the x, so I have x squared. I square the 3, which is 9, and I multiply them together, which is 3x. And then I have minus and plus. So this is your answer. And guys, if nothing else, it was multiple choice. If you multiplied your answers out, you should have come up with 3x cubed plus 81. So if you were unsure, you could have taken the time to multiply the answers out and make sure you had the right answer. Again, some of you didn't take as much time as I would have anticipated. All right, with number 6, it says to simplify, and it's a division problem that involves rational numbers. So you have to, first of all, remember how to deal with division. And basically what we do with division is the division problem is rewritten. We take the reciprocal of the divisor, which is the second fraction, and then we turn it into a multiplication problem. Okay, so to take the reciprocal, you basically flip it over. Okay, you invert it so that it becomes x squared plus x minus 6, all divided by x squared minus 4 times 2x plus 4 over x plus 3. Then the next step is basically you need to factor all of the pieces if that's possible. So I'm going to factor here. So I have x and x, multiply to 6 and subtract to 2. So I have a 2 and a 3, subtract to 1. So I have plus 3 minus 2. X squared minus 4 is the difference of two squares. It factors as x plus 2, x minus 2. 2x plus 4 has a common factor of 2, so I'm going to factor that out. And then finally, x plus 3 does not factor at all. And then we use a process which I call simplify on the bow tie. So if you look diagonally, you have x plus 3 in the numerator, x plus 3 in the denominator. If you look on the other diagonal, you have x plus 2 in the denominator and x plus 2 in the numerator. If you look vertically on top of one another, you have x minus 2 and x minus 2. And then on the other vertical, there's nothing to simplify. So the only thing that's left when you're done simplifying is 2. So the answer in simplified form is 2. Okay, let's see if I can get through one more before I stop the video. Okay, question number 7 says, which of the following equations is an identity? So one of the things you have to think about here in this question is, what is an identity? And basically an identity is going to be a statement that is going to be true all the time, every time, regardless of what value you choose for x. And so basically this involves just trying to see, does the left side equal the right side? Okay, so if I look at this first one and I do some of the math, so I have 6x plus 12x minus 21. I have 18x minus 21. On the other side, I have 18x plus 21. Those are not the same, okay? One has a plus, one has a minus. So that is not an identity. Then you have the second one. If I distribute, and I think this is what a lot of you guys are doing, you're forgetting to do the distribution. You got to multiply the number outside the parentheses to everything inside. Negative 35x minus 10 equals negative 35x minus 10. That's a true statement because the two sides equal one another. Okay, so that is actually an identity. Then if you look at the next one, we have negative 35x minus 10 equals, but it's only negative 31x minus 10. Those are not the same, so that is not an identity. One of the ones that a lot of you guys indicated was an identity, but is really not, is this next one where you have 4 over x squared, and you're saying it equals 8x squared. But guys, look at this. 4 over x times 4 over x. 4 times 4 is 16, not 8. And x times x is x squared. So the quantity 4 over x squared is 16x squared. That does not equal 8 over x squared. So that is not an identity. The next one, you have x plus 5 squared. And again, I think you guys are forgetting the rules in your haste. You have, really, that means x plus 5 times x plus 5. So you have a binomial times a binomial, and you have to use full. So if I use full here, I have x squared plus 5x plus 5x plus 25. That becomes x squared plus 10x plus 25. So if you look at the fifth one, that does not equal x squared plus 25, so that's not. Nor does it equal x squared plus 2x plus 25. So that's not an identity. The only one listed there that is an identity is the second one. Okay, so I'm going to stop the video here, and then I'll start another one with some of the other questions.